Hello everyone, it's me BG Power of grade 10 Maths Subject. Today we are going to explore the nature of quadratic function using GeoGebra. Generally, quadratic function is expressed as y is equal to ax square plus bx plus c. Now we will open GeoGebra in web browser as geogebra.org/classic. Now let's see how changing the value of a, b and c affect the graph. Now let's open GeoGebra. First, let's set the equation y is equal to ax square plus bx plus c in GeoGebra. Here are the sliders for a, b and c. Rule of a: when a is greater than 0, the parabola opens upward, like we can see here. When a is smaller than 0, it opens downward. If we increase the absolute value of a, the parabola becomes narrower, like we can see here. If a is small, the parabola becomes wider. Rule of b: changing b shifts the parabola sideways. We can see here it affects the axis of symmetry and the x-coordinate of the vertex. As I have pointed here. Rule of c: the value of c shifts the graph up and down. It is simply the y-intercept of the parabola. Now let's check the discriminant, which is d is equal to b square minus 4ac. The value of d is 8.48. If d is greater than 0, the parabola crosses the x-axis at 2 points, like you can see here. For d is equal to 0, we are adjusting the value of a, b and c randomly. It's taking a bit longer to make d is equal to 0, but for d is equal to 0, it touches the x-axis at exactly 1 point. Like we can see here, if d is less than 0, it doesn't cut the x-axis at all. So, in summary, in quadratic equation, y is equal to ax square plus bx plus c. A controls the direction and shape, b shifts the parabola sideways, c shifts it up and down, and discriminant tell us how many real roots the quadratic has. That's the beauty of quadratic function. Very simple equation but very rich behavior. Thank you for watching.